Hello. Today I would like to show you how to build a web server completely from scratch for ESP32 Cam. This is just a little bit more sophisticated version of the ESP microcontroller. So let me show it to you a little bit closer. I've just disconnected now. So the actual cam is this part. It has a webcam, a camera that is attached to this connector, and there's also a LED flash which is connected to pin number 4. It comes with card reader. This is a chip. It has a Bluetooth. This is the built-in antenna, and you can attach external antenna, but you have to resolder one 0 ohm resistor in order to be able to use the external one. It also has Wi-Fi. It has a restart button, and unlike the regular ESP32, this one does not require to hold a button for programming. It automatically, the software gets automatically downloaded to it. This one I bought off Amazon. You can see the links in the description. They come in packs of 2, and they come with this, I guess you can call it a shield. It has like a connection, a USB, micro USB connection, so you can connect it to the computer and program it. Otherwise, you can just connect it directly to the pins and program it from there. There is also a reset button on it. So when you connect them together, you have access to the pins and USB to program it. So I'm gonna just plug it in and I will show you on. So the goal after this exercise is to build completely from scratch, from empty Arduino IDE file, a web server where it can take a request from a web page, and then this web page can be it can take a request from a web page, and then reads the request, reads the header, and decides what to do based on which URL you're sending. You can send different commands, and based on the commands that you're sending, the controller can do something with it through its GPIOs. You can turn on and off stuff. So the simplest example would be to turn on and off of GPIO 4, which is the flashlight. So I'm gonna start step by step. First, we're gonna build the Wi-Fi connection, then the Wi-Fi server, then we're gonna build the web server, and then we're gonna build a few functions that we can turn on and off stuff with them. So without further ado, let's start with the code, and the code is fully empty as I promised. So I'm gonna save it as ESP32 live demo web server live demo. I just realized that I might have a problem. I recently created a secondary guest network on my TP-Link router because I don't want to expose my username and password for the Wi-Fi, but I'm not 100% sure that on the guest network my the web server could be accessible to my devices. So I can do Wi-Fi connection. Let me just switch to the benchtop for a second. I apologize for the delay. I promise I'll catch up on pick up the pace in a moment and show you how to do this. Just give me a moment. Yeah, so I'm trying to upload one typical sketch for Wi-Fi and see if I can connect to it to my guest network. Just a couple more seconds. Okay, one moment. So this is, I uploaded a blink sketch on it, how to turn on and off this ESP32 Cam flash light. Okay, so looks like the Wi-Fi network works. So let's go back to the code. And here we go. So the first thing we need to do is to load the library for Wi-Fi connection for Arduino. And I have to mention that ESP32 has its own way of writing code. It uses C++ and it has its own libraries and own ways of writing code for it. But it's very popular because it also can emulate Arduino. That's why everything you use on Arduino you can use on ESP32, or at least most of it. So yeah, the only thing that you need to do is to install the libraries for ESP32, which I can show you in a moment. Arduino library is for ESP32. So let's see. I think usually they are in board manager. No, in order to have this in board manager, you have to add here the location for the additional board manager URLs. And the ones for the ESP32 are these ones. Let me copy it. I'll paste it here. By the way, from where I got it, I guess I got it from this web page. Yeah. So these are the board names. You can Google that by, it's GitHub share content GitHub USER content.com. I don't know this website, but this is obviously the official one. You can I just post this link in the description of the video. So you need this URL, and in order to install the boards, you just have to go to preferences, and in the settings, paste it here. Once you do that, in the board manager, you can you have a new submenu here called ESP32 Arduino, And if you have the same one as me, it will be AI Thinker ESP32 Cam, which is this one. Not to be mistaken with this one, because this one is supposed to have, this is ESP32 S3 Cam LCD, and pretty much none of these was working. I tried them. And then the next thing, you have to select USB port. I mean, with me it was quite easy, because I know this is not this one. This is my Wi-Fi, my headphones, and this is one. So basically it's this one. If you're not sure which serial port you're on, you basically have to disconnect the device from your computer and see which one of these options would disappear, and then once you plug it in, it's gonna appear, and you have to select this one. So yeah, let's get started. So this is completely empty sketch. So let's start. The first thing that we need to do is to include the Wi-Fi library for Arduino, which is done with include, and then we have to type wi-fi.h, and that's it. So second thing is, in order to connect to the Wi-Fi network, we need to obviously use username and password. Not username and password, but it's called SSID, which is the name of your network. So we define two constants, const char, it should be a type char, and then SSID, and my network is named Peter Workshop. This is not my official network. This is my guest network that I created for this live stream. Then oops, I spelled this wrong. And this is password. So my password for this is $$, word 1. Okay. So then we have to define Wi-Fi server type of variable, and we have to set the port to 80. Then we're gonna need a variable to read the header of what's coming. And then the next thing would be to define the setup. So create the void setup. As you know, Arduino requires two functions. One is called void setup, in which we set up the initial setup for our program, and then we have another one called loop, which is continuously executed once the controller starts. So loop, void loop, and then we're gonna put something in it later. So the first thing that we need to do in order to be able to debug, we need to have and give some feedback to the user to see what's going on, is to define a serial port communication. So we start serial begin, and since ESP32 is quite fast and it can support fast baud rates, so we can do 115/200. The only thing is, in order for us to be able to see, we have to set up the baud rate on the serial monitor. So if we go to the serial monitor, if we want to be able to read correctly, we have to set the same baud rate. So let's see. Next thing that we have to do is to try to connect first thing is to write to the user that we want that we're starting to connect, and we're gonna do serial print rather than print line, and say connecting to, and then we want to add the name of the network that we're connecting, so we can inform the user that we're connecting to this particular network. So we do serial print line because we want to be like that. We want to print connecting to better workshop, and then go to the next line. So when we use print, we're printing up to here, and the cursor stays here, and the next command is going to be printed on the same line. But after we print the name, we want to go on the next line, and we go on the next line after we print what we want to print by using print line command. So here we want to print SSID. This is just information. At the moment we're not doing anything. So if we want to connect, we use Wi-Fi dot begin and then we pass two parameters, which are SSID and password. I think if your network does not need password, I think you can pass it with we can do this with only password, with only SSID. Of course, you cannot go without SSID, because if it's without SSID, it's not gonna know where to connect. So let's try. If it compiles, that means that the password parameter is optional. And so far it looks like it's compiling. So yeah, if you don't have password, you can just let's see if it's gonna compile successfully. Yep, it didn't give me any error. I don't know if it's gonna connect or not, but at least it's legal to do it without password, without compiling. So, all right, password. Then, while this thing is happening, the Wi-Fi has a status method that has different values based on what's going on. If it's connect, it's going to be connected. If it's connecting, it's going to be connected, and so on and so forth. There is a status at which we are connected, which is called WL connected. Well, let me see if I spell it right. Okay, connected. So once the Wi-Fi is connected successfully, the status becomes connected. So we want to not proceed until the status becomes connected. So we want to stop, and we don't want to do anything below. So what we can do is we can use while loop and do while until this thing is different than connected. So how we're going to hold it, we can use delay, which stops the entire controller and waits. So let's use something small. Every half second we check, and if the half second passes, we want to print something to show the user that something is going on. So we can do serial.print, and we can do pluses or dots, so we can print 1 plus, let's say. So that means it's trying to connect. It's like a loading symbol. So basically, if it's in status connecting, this is going to be false, and sorry, it's going to be true because it's not going to be connected, and it's going to wait for a second, then print 1 plus, and it's going to go again and just check, is it connected? No, it's still connecting. which means this one is true, and it's going to go another half a second, and so on and so forth, and it's going to print pluses until this thing gets connected. And when it's connected, it's going to get out of the loop. So the next thing we can do is we can once we're out of the loop, that means we're already connected, so we can say serial dot print line connected to Wi-Fi. Then we can do, we would like to see the IP address on which we're connected, so we can do serial dot print line IP address. And by the way, we should, IP address that we will, and then we're going to print it on the new line, serial dot print line and then we're going to use Wi-Fi dot local IP method. Okay, and then we can start the server dot begin. I think this is a good place to do a test run because we wrote a lot of lines, roughly 30 lines. If you compress the white spaces, maybe 15 lines. And let's see what's gonna happen. I'm gonna turn cam and show. Done compiling. Let's try to upload it. Okay, hard resetting with the pin. Let's see, serial monitor, clear output, reset. I press the reset button, and from my experience, if it doesn't connect on the first second plus, it's not going to work, so I just have to reset. And it is not connecting. And I think I know what the problem is. I think the problem here is I don't know how to spell the word word. So the password is password1. So I'm gonna upload it and test it again. Compiling sketch. Okay, so let's open the serial monitor, clear output and reset. Didn't connect. There you go, now we're connected. I've noticed before when I was playing with it, when you write, when it doesn't connect from the first time, from the first plus, it basically never does. So I think every second time it does it. So if I reset it now, it connects. See, there's only one plus. And then, maybe I should have put one new line in between these two, because I don't want to have plus and then connect it to Wi-Fi. So anyway, this is the IP address which we received, and let's see if we can see something at the moment, just out of curiosity. We're connected to this IP. I mean, we're giving this IP, and let's see, 192.168.0.154, and for now there's nothing, because nothing is listening on the other side, or at least nothing is handling requests. So the first thing we want to do is, first I want to add a new line before this one, serial dot print line, and put empty string. Okay, so now once we have a connection, we would like to create something to listen, and the first thing we define is a client, Wi-Fi client. Question is why like this, Wi-Fi client. Yeah, it's going to be named client, and it's going to be coming from the server dot available. So if a client is available, it's going to be assigned to the client variable, and then we can use if client. Then we need to define a time variable to keep the current time and check for the time that passes since the request started, and if it's too long we have to time out. So the place where we can declare these things is in the beginning, so we can keep current time into unsigned long, which would be current time, and this comes from the milliseconds. This is the milliseconds that have passed since the beginning of since the Arduino was started, and then unsigned long previews time, and initially we're gonna put this one as 0, and then we want to have a timeout, which would be 2 seconds, and this would be 2000 milliseconds. So const long time out time equal to 2000. So once we have these three declared, we can once we have a client connected, we want to start set the current time to be equal to the current milliseconds. So we do current time. The problem with this IDE is it doesn't do too much autocomplete and recognize the names of the variables, so you have to make sure you type incorrect. So this would be the current time, and then we want to set previews time equals to current time. And just to make sure I spell this difficult word, I'll just copy it from here and paste it. So these are, then we can say to the user serial print align new client connected, and let's see if this thing is gonna work so far. So basically now we should be able to see if the client can be connected. So we will see if the server is working at all. Okay, so let's go to the serial monitor. Okay, we're connected, and let's go to the web server address. Okay, well, we have a client which is available, but we're not closing it. So that's why it's printing, because the browser probably made several attempts to connect, and that's why we're having so many attempts. So let's try to reset it, and yep, no new clients now. Okay, so once we have a client, we have to check how long it took. I mean, how much time passed since we started to read from it, because if it's more than 2 seconds, it timed out. So we can check that by using well, we have to check 2 things. So we can use client dot connected method, which returns boolean and says if we're still connected, and also we have to know if we didn't time out. So the other thing that we have to check is if current time minus previous time is less than time out time. So equal or less than equal. I'm gonna again copy those things, because as much as I would like to type everything by hand, this IDE doesn't really do any autocorrection. So we want to do while again, while these 2 things are true, while we're still connected and we didn't time out, then we should do something, and we should read the header, and once we either timed out or we got disconnected, we would like to queue the client. So we do client stop, and then we say serial.print line the client was disconnected. And then we do serial print line just to make more space. Okay, so let's try that again. Maybe we'll time out and it's gonna disconnect us. Yeah, of course, I didn't copy something properly. I should probably make a tutorial. First of all, I have to learn how to do that and set up Visual Studio Code as the IDE, because Visual Studio Code is proper IDE. I mean, it's not a IDE in theory, but it has a proper IntelliSense and checks the spellings and all these things. And here you have just a basic color coding. It doesn't really check much, doesn't check anything, and you end up like mistyping things. And we want to develop stuff, we don't want to win spelling competitions. So let's go back to the serial monitor, clear, reset second time. There you go. And let's see if this is gonna get disconnected. Boom. It says new client connected, but it doesn't try to connect multiple times, and it does not get disconnected for some reason. And the reason is that I'm not changing the time inside of the loop. So yeah, good. And that makes sense. So the first thing that we have to do, of course, in this while, in order to time out, we have to do current time equals to millis, and then initially you're setting the current time to millis, then you take the same as previous time. So basically when the client opens, this is what the previous time becomes, and the first time you get into the while, both are the same, so the result is 0. 0 is less than the timeout, so we get in. Then we take the new millisecond time, and then we start looping and changing this time at every loop until the timeout becomes, the difference between the two times becomes larger than the timeout, and then we exit the loop, we close the client, and we print that the client was disconnected because it was too long. So if you have the patience and bear with me, you can see this, and hopefully this time it will work. Okay, so let's open the serial monitor, reset, clear, reset, and then open this. It's timed out because this one stopped, and it says client, a new client connected, client was disconnected. So perfect. So far we have timeout. Let's see how to actually do something useful. The next thing we have to do is to check if the client is available, if it's sending any data. So we do if client dot available. This is a method, and what we can do, we can, if it's available, which means if it's sending any data, we can start reading it, and we can do this in char code C equals to client dot read, and then as we discussed in the beginning, we had a string which we keep the header. So every time we read something, we put it into the header. Header plus equals C. And then let's print it just to see what's going on. Serial dot print C. Actually, no. Yeah, we can do right. Yeah, print's fine. Let's see. Yeah, print's fine. Let's see what we receive. Should send us everything we got from the client, from the web server. Sorry, from the web browser. So we going in zero monitor, clear, reset, we're connected, we're going again to here and open, and wow, most likely I would have to close the page because the browser is keep trying to get this. So let's stop that. Please stop. I don't want you to spam my. Okay, so basically new client connected, and this is what it says. Sends. It sends. This is from the request is from here to here, and every request ends with an end line, with a new line. So this is how we find out that the request end, and in this part here shows the URI. So this is the URI. So if we send something after the let me show you. So this is basically, it looks like this: HTTP colon / and then we have slash at the end. So if we send this is the base URL, and as you can see, it only shows you slash. But if you put something after that, let's say pin 4/off. So these are this part is behind. You can have different URLs, switch to go. You can choose one from on to off, and you can check for this thing in the header. So let's try like this, and you see now. I need to pause that because it's bugging me. Stop. Okay. So now you can see that instead of passing you only slash, it passes pin 4 and off, and we can scan inside of, we can search inside of the header and find if this if we can find this string. This means that someone wanted to go to this URI, and we can do some work with it. We can turn on and off the pin. So the next thing after we have this is to check if C is equal to the sign for new line, which is \n, then we can do something. So we can do 3 things. Actually, the first thing we have to check we have to check if this is equal to R, which is the return symbol, and if it's equal to R, okay, we need to define one more variable, which would be named current line, and this current line would hold the current line of the request. So the request, sorry, I'm clicking the wrong thing. Tools, zero monitor. So our request is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines. At the end of each line we have \R for return, and then at the beginning here we have \n for a new line. And in order to know that the header is finished, we want to see a sequence of /n/r, which means we have to read every line in a variable, and when we see n, we have to check if we have to when we see r /r, we have to check if the length of the line is 0, because here we have r and the length of the line is not 0, which means this is the request is not over. Then we go to this r, and then the length of the line is not 0, so it's not over. We continue reading and then keep going and going and going, and once we get to here, we have a new line, and then we go to /r, and the length of the line is 0, so this means the request is finished. So the way to do that is we have to define another variable called current line. The current line can be a string, and one second, let me think how to do that. Yeah, we can do a string. So we can define it, let's say here, string current line equal to empty string by default. So now every time when it's not /r, we want to add the content of C to current line. So let me go back to the serial monitor. So every line finishes with R. So we read is it R? No. So we put this, because the way the client reads is letter by letter, character by character. So the first time when it gets in the loop, it gets G. The first thing it checks is C, which is G, is different than /r. No. So then you put it in the current line. Then it reads E and puts it in the current line, adds it to the current line, and so on and so forth until it gets to R. The moment it gets to R, it has to check if the length of the line is 0. So let's try to do it like this. Else, if but then it's gonna read the end. One moment, let me think about it quickly. Yeah, okay. No, so we have to check if, else if C equals to /n, which is the beginning of the line. Again, let me show you here. So serial monitor. So every new line starts with \n. So we read, and we're checking, and if it's not equal to r, adds it. But then when it gets to n, it's gonna add the n, and this is not what we want. Actually, this needs to be swapped. So it's gonna be, if it's equal to n, it's better to be equal to n first, and then we do some stuff here. Oops. And this is if it's different than r, we do that. Okay, so it's gonna check if it's equal to n, then we'll do something. Because it's a new line, we have to check if the previous line had some content, and then if it's not n, we check if it's different than r. This means that we're somewhere in the line. So the request looks like this. You have \n and then content, and then you have \r, and then you have \n. Actually, I'm not sure if in the beginning you have \n, and then you have another more content, and then \r, and then this thing repeats several times until at the end you have \n, \r. So we check first if it's equal to \n, so we're here. We do something, we check if there's a content in the line. If it's not equal to n, if it's not equal to r, and this means it's not equal to n as well, because otherwise we would have been here. That means, so if it's equal to n, it gets here. If it's not equal to n, comes here, and then it checks if it's different than r, which means that it's different than n and different than r, which means it's a content that we want to put into a line. This is going to be this part and this part and this part. And here, if it's n, we want to see if the previous line is empty. So what we do is we check if current line dot length, this is a method, equals to 0, and then we'll do something. Let's say send a response, then generate web page, and then do something with the GPIOs. Else, which means if the current line length is 0, that means we're over, we're out of the, we received the request. Else, if it's n, that means that we're either here or here or here or here. And I think it's /n/ like this, and basically there is one more /n here. Okay, so Actually, yeah, in reality, it's like this. /n, 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 and then it's like this. So if the current line is different, then length is different than 0, which means there is a content. It means we're still reading the request. We have to 0 this line because we're going to be starting to read the next line, and this is going to be like this: current line equals to 0. I mean, not to 0, to this thing. And let's check if this works by sending serial.print line request received. Okay. Oh, one more thing I forgot is, first of all, yeah, this thing needs to become comment, and then one more thing is, if I get to the end of the request, I need to break from this while. Otherwise, we're gonna keep going and going. So I mean, we're gonna keep going until we time out, but we want to get out of it before the timeout once we get the request. Yep, I did not use the right quote because this is a char and I'm using double quotes, and this is used for strings. And one more thing, once we're out of the loop, we have to do header and clean it up. We have to clean the header because the next client doesn't want to know about what was in the previous one, because this is still in the loop. And let's see. Alright, so go to Tools, Serial Monitor, and not connecting. This time it's connected, so let's try by sending a request. Okay. It did not get any response, but the nice thing is request received. So we got inside, we got to the end of the request, and we read it successfully. This is good. This was the whole point of trying to read the header. Okay, how do I turn So let's continue. So we have to do something here. First thing that we need to do is send a response. Response is what the web server sends to the client to acknowledge that it received a request and that it can reply to it or not. There are different codes, but if you are successful, I mean, if you understand, if the server understands the request and can return the information, it sends 200 OK. So what we do is we need a function, because I don't want to write here this, I want to keep everything tight here. So I'm going to just define a function called send request, and this function it would need send response, and it will need to get the client. So we're gonna send the client to it. Okay, so this function we have to define after the loop, and it will be I'm just gonna copy this, and it has to take y client, name client. And what we're gonna do is simply gonna send headers. I mean, we have to send a response, and the response is client dot print line. We basically print into the client and say http /1.1 space 200 OK. You should not change that. This is by the HTTP protocol. You can read about this. Client print line, and then we can type do content dash type text /HTML. This tells, the first line tells that it was success, and second line tells the browser to expect text HTML. And then we have client print line connection close. And then we always have to finish with the empty line, blank line. Client print line. So this is how the browser understands that it's over. Okay, let's see if this works. This is strange. What's wrong with this function? Oh, I need to tell it what type it is. I mean, what return type it has, which is void, which just means we don't return anything. Okay. Compiling, uploading. Okay, so let's turn on the serial monitor, do a reset. Come on. There you go. So we're connected. Let's try it again. Boom. and yes, we received an answer, and the answer, the response was okay. And you can see here, new client connected, new client disconnected. So this was perfect, everything was executed correctly. So now we can return a content of this web page. So we can fill up the second part, which is we can make a function called send web page, and this would also require a client, so we're going to send client because we want to write to it, and then we make a second function called void send web page, and it has Wi-Fi client code client, and in this we can start printing, and client print line. By the way, I'm going to put this one in the clipboard so I can, because I'm going to need to use it a lot of times. So every web page starts with so less than, and then exclamation point, doc type HTML, and then we close the HTML. Like this. Okay, let me see if I misspelled it. Doc type HTML. This is the first thing that you have to send in HTML5. Okay, so then we paste this, and actually, why don't I just save this, okay, into the clipboard? And the next thing that we want to send is head, and in the head you can put a title, and in the title we can put this is ESP32 Cam custom web server title head. Okay, and then the next thing we can do is put a body. In the body we can put H1 to make it like large, and we can say ESP32 Cam custom web server, and we can close the H1, and we're not going to close body. I mean, we can, but I think the page is still going to be generated and considered as valid. So let's give it a try and see if we can actually receive this web page. This is very simple HTML5 page. You send the doc type, we have the set in the head. I mean, you send the HTML opening tag, then you send a head title, which would be printed on the browser's title bar, and then you create body H1, and then we're gonna have to just see one big label called ESP32 web server. Let's see. Let's open the serial monitor. I think I screwed it up. I should have waited. Yes, sorry. You're gonna have to bear with me. Alright, so we restart, go to serial monitor, we connected, and now we go to, this is the moment of truth, and boom, we have a web server and we had received an answer. And see, this is a ESP32 Cam custom web server, and this is our source code, which we can see by right clicking. And how do you see the source code in this stupid? What? It used to be like right click view source. There you go. See? Doc type. I hope I spelled it right. By the way, I think I can send \ends like this to structure it nicer. Let's see if this is gonna help. I'm not 100% sure. Let's give it a try, and in the meantime I'm going to start writing. So one thing that we need to define is a string variable in the beginning that we're going to use for status of our flash, which will be string flash status, and the default value will be off. Okay, now okay, so let's see if it's connected. Yep, connected. And one more time, look at the page. Oh, where's my browser? \n helps. So see now, HTML, head, title, body, everything's on your line. I can probably use some / something to do the indentation, but that doesn't matter. This is just, browser doesn't care. It's only for the user. So the next thing we can do is we would like to print the status of our pin, which is flash. So we do actually, yeah, I have this one, and the name of this was flash status. Flash status. So what we're gonna do is we're gonna print. We're gonna create P, and inside of P we're gonna create GPIO for state is, and then we're gonna concatenate, and then we're gonna concatenate, and here we're gonna add P \n. Okay, so this will print the state of the flash, and then we have to create a button to turn it on and off. So if flash state equals to off, we have to print a button to turn it on, and this would be P and A, which is hyperlink, ref equals backslash, and this would be pin 4 slash on, and then we have to close the quotes, and then we create a button, and we just print the word on, and we close the A and do \n. Let me see if this is valid. So no, we have to also close the P. Okie dokie, so we have a paragraph and we open a link. This link goes to slash pin 4 slash on, then there's a button on, and we close this, and then we close that, and then we put a new link. So this is if the state is off. Else we have to print the same thing, but with the state, with the status to go to a URL off, and yeah, that's it. Okay, so instead of explaining, I'll just try to upload it and show it to you. Basically, this prints a link. Oops. What's the problem? Yeah, spelling bee. I want to curse big time now. Oops, here it has to be off. And here has to be off. And by the way, we should just finish this because I think the only thing we need on this web page is to close the body and then close the HTML, and that's it. This is the entire web page. So we want to have a button to switch on and off the flashlight. Super simple. This is like only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 lines of code to generate the entire web page. Super simple web page. Oof. Not sure what's going on, but let's turn off. I just turned off my crap. Did I just burn my ESP32? Wow. my USB doesn't want to turn on now. Let me see what else I can disconnect without making a big problem here. This is the keyboard. I guess I can disconnect this cam. Okay. Okay. Port. Alright. Yeah, I use another USB. Did I just burn my USB hub? Oh my god. Oh, okay. Finally started. Whew. Alright, so let's go to serial monitor. 2222, okay. This one was different. Serial monitor, reset, another reset. Good. So now we go to the web page and see if we have a result. This would be, nope, not this one. There you go. So let's reload, and the GPIO4 state is off. And if you hover over this thing, you can see at the bottom here in the status bar that it will send me to pin 4/on. And you can see if I click this one, I go to on. So this would depend on the state. Okay, so now we can switch, we can send commands with the buttons, and but now we have to do something to start on and off the pin. So for that we would need a variable to define where this pin is, where the flash is, and this would be which we should do would be const, because it's not going to change, it's end, and it's going to be called flash pin, and is equal to 4, because as I said, the flash is mounted, is connected to pin to GPIO 4. Then we have to, in the setup, so let me just put together all the definitions here, and then in the setup we have to make sure that we set the pin mode for 4 to be output, pin mode to flash, not pinned mode, I don't know why I'm writing this, mode flash pin to be output. Okay, this one we can even set in the very beginning, and we can set up the serial monitor, and then we can do the Wi-Fi. So set up the pin for the flash, set up the Wi-Fi. Start the server. Okay, we don't need this anymore. And as we said, we have to do something. So we're gonna make a function called do something. Oh no, we have to also set initial state of this pin here, which would be low. So we have to do digital right, and then the pin is going to be flash pin, and then the state would be low because we want it to be off. And then we have to define a function do something, which would not take any parameters. And this function is going to be void do something, and it's going to do the following thing. We're going to take, so if you remember, we have this header in the loop. I mean, initially we have a header string in which we keep the header from the serial monitor that you saw, which we keep. Let me send a request. So this is the header, and this is the header, and the header, oops, why? Boom. So this should be part of the request. I don't know why it's sending fav icon ICO. It should be like this. I guess this is sending a second request for the fav icon because it doesn't get it. This is a request sent by the browser. But anyway, so if let's see if I clear that, and yeah, I sent one request like this, turn on the flashlight, and it sends to one is sent by me to this request, and one is looking for this file, but I don't have this file, so that's why it's sending a second request, and I'm getting the same response to it. So I'm sending the same response to it. So what we're gonna do is we're gonna check if in this header, every time it finishes with the client, so if you see if, no, actually while it's connected, and is getting the information about this header, and when it breaks from this while and goes here, like zero, cleans it up. But it breaks after it does the response, the web page, and to do something thing, and then it breaks and then it clears. So every time we have a new client, we have a new header. So this header, we can use it because this is defined in the beginning, and it's accessible in the entire program. It's a global variable. So we can take this header and we can check if in this header there's index of, and we can search for this phrase or this string, which would be get space slash, let's see, what was our request? Our request was serial monitor. Our request was get space pin 4 on. So I'll just copy this one to make sure it's correct. And if the index of this thing, which means it's going to take the entire string of header, and it's going to search for this substring, and if it finds, it's going to return the index of this thing and of this substring. So we can check if it's equal or greater or equal than 0. So if it cannot find it, it's going to return -1. If it finds it, and if it's index 0, it's going to return 0. If it's 1, it's going to return 1, and so on. So if we can find this, then this means someone is sending a request to turn the pin on. And what we need to do is to set the flash status to on, because we want to say to the web page flash status equals to on. Then we want to turn on the flashlight, which would be digital write flash pin high. And then we have to search for another thing in the header, which is off. And then we have to set the state to off, and then we have to throw this to low. And let me think. I'm thinking that I'm setting this state and then I'm turning on, but this do something is ran after we send the HTML page. In the HTML page, we're using this flash status, so we want to run the do something before and the send page, because in the do something we're changing the state, but we want once someone, hold on, if someone requests the page, first we're gonna send this, then we're gonna set the state status, and then we're gonna generate the page. So the only thing we need to do is do something has to be before send web page, because we're generating the part of the content that we're returning on the web page. So we're sending response, we're doing something, and then we're generating with this do something a status and generating a new button. So this should implement fully the web server. Crap, do something. What? I cannot spell a single word. Please don't crash. Okay, so let's run the serial method. We connect, and I'm gonna turn show code and open the browser, and let's send first to off. Okay, so right now if I click on, boom, it works, and see, but the state is still on, off, on, yeah, the state is on, and the light is on, boom, the state is off, state is on, state is off, but sometimes this doesn't change. Oops. Right, okay. Okay, she's gonna turn it on. let's try to put this one in. How do I split the screen? Okay, and this one goes here. Come on, macOS, don't be so dumb. Everyone knows you're dumb, but don't be so dumb. Okay, so this is on, and we have to click off. But why it's taking so long? My guess it's not always detecting the... What is going on? Let me refresh. Come on. Did I screw up my Wi-Fi? No, just disconnect this. Disconnect it again. There you go, we connected. Alright, so the status is off. Let's turn it on. Then let's turn it off. Then let's turn it on. And let's turn it off. So now the flash is not off and the state is off, and then the button says on. So now the problem is the state is off. I know the state is on now. Okay, so we turn it off. And now the state is off. On. Off. And even for more fun, I'm gonna try this from my iPad. Because usually this is what we want to do. I'm gonna turn the code, sorry, not the code, but to benchtop, and we're gonna do 192.168.0.154. And as you can see, we have the same web page. What? There you go. So you can see no connection between the two things. So I just click on, and it says it's on. Then I click off, and it's off. Now on, and it's off. Boom. So yeah, the code is quite simple. I just put it on my GitHub and then put a link, and also put a link to the webpage where you can download the different boards for the board manager of Arduino IDE, and as well from where you can buy this nice microcontroller. I will make a shorter and tighter tutorial for how to set up like a real proper web server where you can serve full pages, not generate them by functions, by line by line like this one. But basically you can control something remotely from your phone or a computer that is connected to a GPIO pin on this controller by a little over 100 lines. I mean, if I clean up the white space in the comments, it will be around 100 lines. So it's not that much. I just put it in my GitHub and post the links in the description of this stream. I hope this was useful for someone. If you like it, just subscribe for more. Thank you and bye bye. See you next time.